A stochastic process assigns a value to every moment in time, but the collection of all possible paths is what constitutes the ensemble. Survival is a property of a single path. It either crosses the absorbing barrier or it does not. Expectation is a property of the entire ensemble. It averages across all paths simultaneously. These two objects are defined on different mathematical structures. Confusing them is the source of survivorship bias. An absorbing state is one the process can never leave. Once entered, it holds permanently. The stopping time is the first moment the process enters that state. If the process never reaches the absorbing state, the stopping time is infinite. Survival means the stopping time is infinite. Not that it has been avoided permanently, but that it has not yet occurred. The survival event at time t is the set of all paths that have not been absorbed. Conditioning on this event creates a new probability measure. This new measure assigns 0 probability to absorbed paths and redistributes all probability mass among the survivors. The denominator is the survival probability, which shrinks as time increases. This is not a correction. It is a change of the mathematical object you are working with. The unconditional expectation includes all paths in its average. Absorbed paths contribute 0. They drag the mean downward. The conditional expectation excludes those paths entirely. Only the high-value survivors remain in the average. The gap between the two expectations grows over time. As more paths get absorbed, the conditioned expectation becomes increasingly divorced from reality. Taking a limit and conditioning on survival are two different operations. They do not produce the same result when applied in different orders. In the gambler's ruin, absorption is certain for every path. Yet the conditioned expectation rises over time. This is because conditioning selects paths that have survived longer. Those paths look like they are drifting upward. But this apparent drift is a selection effect. The underlying dynamics have not changed. Conditioning on survival selects the low-hazard subpopulation of paths. Paths with a low tendency to be absorbed are overrepresented. These paths tend to carry higher values, so the conditional expectation is systematically above the unconditional one. This is not an error in measurement. It is the mathematical consequence of restricting the sample space. The apparent improvement is a selection artifact, not evidence that the dynamics have improved. Conditioning on survival is a descriptive operation. It restricts the sample space to those paths that have not been absorbed. It does not remove absorption from the dynamics. It does not provide a decision rule. Statistics computed on survivors apply only to survivors. They cannot be generalized to the full population. The conditional expectation diverges from the unconditional one. That divergence is the signal, not the noise.